You're live. There you go. All right, let's do this. We're on. Yeah. Hi everyone, welcome back to the second episode. We're looking at the Arduino 101, and I think last time we did the SIK, we introduced that one. I'm Sean Hemel, I'm one of the creative technologists, and I've got Derek with us today.
Hello.
I'll be helping host some of this, answering questions, watching the chat. If you have questions, please post into the YouTube chat, and I will do my best to ask either one of us, post it to the teachers, or ask Derek over here to see what he has to say. And I think we're going to be looking at what you can do with the Arduino 101 in the classroom and taking it beyond just the kit.
Yeah, because the kit itself has a pretty good distance, a span of what you can do in the classroom, but there are a number of software layers that we can lay on top of the kit to extend students' learning, take it into different realms of interest for students' learning. But most importantly, Sean, we have some teachers, right?
Oh, we do. Why don't we go around the Google Hangout and have the teachers introduce themselves?
Most importantly, Sean, we have some teachers, right? Oh, we do. Why don't we go around the Google Hangout and have the teachers?
All right, start. I'm Nick Peterson. I'm from South Carolina. I've been working with integrating technology in the classroom and having students be the ones that lead that initiative.
From South Carolina, I've been working. Perfect. That was Nicholas. Ian, do you want to go next?
Just unmuting. Yeah, I do. So I'm Ian Phillips. I'm the director of computing and ICT.
Perfect. Tony, do you want to go next? Tony, do you want to go next? Can you hear me?
Sure. So my name is Tony Gilbert. I'm a computing lecturer from New College in Swindon.
Perfect. Thank you. Thank you, all three teachers. You are Intel Rockstar teachers, and we're going to be going back to you guys for more information and questions and things like that about using the 101 in the classroom. We do have some technical difficulties with audio that we're working on, so hopefully we can get that straightened out over the next couple minutes.
I've got a couple initial questions for you, Derek.
Okay.
How much does the kit cost? It looks like for the, I believe the 101 kit, this is from a YouTube question.
Perfect.
I believe it's $150 if I'm looking at the correct SIK here.
Yeah, so we have individually, and then there's also volume discounts associated with it. So if you're looking at a standard kind of classroom volume, you can look at the lab pack, which you save some money there. But then also we have volume discounting after that. And then if you contact one of our program managers, education program managers, you can actually, we can work with you on some pricing as well.
Cool. And then another question, how can we use the Arduino for the higher voltage controls?
So that's something like using a transistor or a MOSFET. So there's actually a circuit in using a transistor in the kit itself. So that's essentially probably the most basic way to control higher voltage, other than the onboard 3.3 volts.
Good deal. So moving on from that, we're here about the 101 SIK. What are we going to focus on today with it, other than answering as many questions as we can?
Yeah. So the basic thing, we're going to do a little bit of a tech talk today. We're going to explore two apps that you can use with mobile devices. One of them being an app called Blink. Another one is Google Science Journal. Both of them have great applications in the classrooms. One looking if you wanted to do something around Internet of Things and kind of remote sensing, remote control with the BLE on the 101. The other one is data collection and being able to really integrate data collection back into a lot of your Google apps. And that's, you can actually even use that with a Chromebook, which is actually a really nice addition to the 101. And we're also going to mention briefly and just cover the ScratchX extension for the 101. Able to use Scratch and control the 101 through Scratch. And so we'll talk about that briefly. But first, let's go to Blink. So Blink is an app that works with iOS as well as Android phones. It's free to download, and it allows you to basically interact with a number of pieces of DIY hardware, the 101 being one of them. And we have actually a really quick demo of how that works. So on my phone, I've actually installed Blink. And I can open up the Blink app. This is the project that we're going to demo here pretty quickly, is just basically connecting the 101, which has a Blink sketch on it already, running on it from Arduino, and I'll show you really briefly where to find that in Arduino itself. But be able to connect to it, things like that. So just briefly, I'm going to stop this app, and I'm going to start a new one just so you can see how easy it is to create a new project. We can select from boards, and there's a number of different boards. The Arduino 101 is at the top. And then there's a connection type. And that connection type is Wi-Fi, USB. So if you just have a standard Arduino, you can actually connect to Blink via USB on your computer or laptop and be able to control it via that way. But we want to control it via BLE. So I'm going to select that, hit OK, and I'll create the app. And now I have a new project. It's an app called New Project. I didn't rename it at all. And then for me to add interface pieces, I can just click button, and I can move this button around anywhere I want it. And then when I open it, I can use it as a push button, momentary push button, or a switch. I can name it. And then I can give it what pin I want to control. In this case, a nice hello world on pin 13. And that is how, and then pretty much I'm going to back out of this because we're done. And since we're communicating to it through BLE, I have to add a little BLE widget. And that's further down right here. Once I add the widget, I need to connect to my board. Should be named Blink. It's not on there yet. Never works on demo day, right? I'm going to open up Blink again. I'm actually going to use this app. Make sure that I'm connected. So it's Blink is connected. Play this, and there we go. So I think my primary problem is that this app, the app I already made, was already connected to this board. If you want to play around with Blink a little bit more, I'm going to pull up Arduino on my laptop here, and we're going to screencast it. And I'm going to show you in Arduino where you can find this. We good, Mike? Yeah. Okay. So under Sketches, we need to include the Blink library. So we go to Manage Libraries. And then you can type in Blink here at the top, B-L-Y-N-K. And as you can see, I've already installed it. and install the newest version. And then under my examples, once I've changed my board and port to Arduino 101, I can go File Examples. I can go down to Blink. And I have boards Bluetooth Arduino 101. And that's the sketch I actually have open right now. The only thing is that when you create a Blink app, you get an authorization token, and it gets emailed to you actually when you first create an app in Blink on your phone, and then you just cut and paste that into your sketch. And that is really all I change in this, and then the creation and creativity portion of this is all done on the phone. So very little text-based coding to get some basic command and control and data acquisition on a mobile device, tablet, phone, you name it. So
I've got a couple questions
Yeah.
from YouTube about Blink. Somebody was asking on YouTube, what's the app name? It's Blink, B-L-Y-N-K.
Yep.
Does it come with the chip? What language can be used to program it?
Oh man, so the best place to go is blink, blynk.cc. There are a number of microcontrollers, single board computers, and APIs in terms of programming language. I know I've used Blink in Node.js, and I believe there's also some Python plugin. But if you go to the website, their getting started documentation is phenomenal. It is probably some of the better app development platform documentation out there.
Cool. Thanks, Derek.
Yep.
So giving it over to the teachers now, what are your thoughts on Blink? Have you used it before? Do you see it as an entry point into the world of IoT for some of your students? If any of the teachers want to chime in on that.
I've never used Blink before. I think it would be quite good for secondary schools, primary secondary schools, and certainly in college. We've done something similar with the Galileo board. So we managed to get students to tweak the board to unlock a door lock using IoT, which was quite cool. But yeah, I think Blink's a good starting point. I'll definitely use it.
Perfect. Anyone else?
I haven't used it yet, but I do see the potential more kids could be bring your own the boards, go back and fix what they need to tweak and the like. So if you're doing whole class and don't have 25 to 30 Arduino boards in your room, that'd be a quick way to link it so that it would work.
Perfect.
Good deal. What is this thing about the Google Science Journal app? Can you go into that?
Yeah, so we actually have a demo here as well. The Google Science Journal app is a free app produced by Google, and it's a way that everybody has essentially a computer in their pocket. And so how do we leverage this? And not only the onboard sensors on my phone, but how do I start connecting other hardware to my phone and Chromebook and tablets, you name it, to be able to collect data and do some citizen science in the classroom, so that it is not your students taking your word for it. It is definitely I am collecting empirical data and being able to harness that and be able to show proof of a certain concept. So I actually have the Google Science Journal app on my phone here. And I'm actually going to get out of Blink. And I've swapped out to a different Arduino 101 setup. So this is the 101 with the Blink firmware, not Blink, the Google Science Journal app firmware. So we currently actually sell a Google Science Journal app kit. And what it is essentially the 101 and some components, cardboard components and hardware components. The 101 board actually comes preloaded with the Google Science Journal app firmware. We're currently working with Google to make that as easy to upload to any other 101 board as possible. There are kind of two ways to do this. There's an Arduino sketch that has a number of library dependencies on it. So there's kind of a walkthrough process of being able to find those libraries, install them as you would any other Arduino library. And then there's also the raw kind of C++ that needs to be compiled, and there's a process for that as well. So for this, we actually just started with the preloaded, pre-flashed board. It has a light sensor circuit hooked up to it, so it's a light-dependent resistor and a 10K resistor wired in a voltage divider. That you can actually, it's the same circuit you would find in the Inventor Kit experiment guide. And then I'm going to open up the Google Science Journal app on my phone. Oops, Google Science Journal app. And right now, so I actually added this earlier. So these are all the different sensors that I can read and collect data from. The ones that are internal sensors on my phone, the ambient light sensor, which is actually right here on my Samsung. Obviously, the phone has a microphone, so sound intensity. The accelerometer data coming from my phone, and barometric pressure. So just my phone alone has a number of different uses that we can collect data with. Super useful. And then I'm able to add devices to this. So one of them is a custom Bluetooth device sensor, and I can pick which Arduino pin I want to look at and collect data from. So this sensor circuit is hooked up to A0, and I can just hit OK. So now I have that custom sensor added. I can hit back, and it's going to load the sensor data here, and you can see I'm getting 930 out of 1023. If I put my finger over this light sensor, that light will go down. The great thing about this being BLE is that I can actually take this circuit and I can slide this thing under the table where it's really dark, and it changes the value even more. We have a lot of lights in here because we're being filmed. Now, you probably noticed the alert me when the sensor is below 600. And one of the great things about this app is that I can enable or edit triggers. So I can set a trigger to alert me when a value is below something, and I can use a drop-down menu here, at a value, below a value, drops below, and then I give it a value, and then the type of alert I want. So sound, vibration, visual notification, all that fun stuff. So if I go back to us collecting data, if I want to record this over time, I can actually hit the record button, and it will start at a certain point, and as that data changes, it's recording these data points. I can hit stop, and now you can see I have a working graph of what that data was over time, and I can hit play. This is playing an audio version of what this looks like, so you'll hear it go lower. So not only am I seeing the visual, but also some of what this looks like from an audio perspective, as well as some of the processing or data processing. So minimum value was 764 over that time period. The average was 907, and the maximum value was 934 over the 14 seconds. I can add some notes if I wanted to as well.
Cool. I got a question from YouTube. Do all the programs come pre-installed in the app, and what about custom applications? I believe they're referring to the Google Science Journal app.
So the Google Science Journal app a lot of this stuff comes preloaded. So I'm trying to understand the question a little bit more. So the app itself, basically you create a project, you can create the triggers on its own. It will automatically find whatever internal sensors it has on your device. So I didn't have to go looking for the accelerometer and point it at my accelerometer or my barometric pressure sensor. Those things show up automatically.
Whichever device, whatever you have on the, say, 101.
So the 101, the easiest way currently to do this with the 101 is to buy the Google Science Journal kit from us. It comes pre-flashed. And then we'll post links, I think, in a little bit around where to find, if you already have a 101, where you can, the instructions for being able to upload that, if you already have one that doesn't have the firmware installed. But again, you basically tell it what pin the data looks at, or the journal app it looks at. So A0 right now, if I had another sensor hooked up to A1, I can actually add a second sensor and we can look at both of them at the same time. Hope that answered the question.
We'll see. I hope so too.
Yeah.
Are you good with the demo?
Yeah, I think we're good to go.
No.
What do the teachers think? The teachers think about this as a kind of another layer to be able to add on and maybe even collaborate with their science classrooms.
Yeah, I got also a question in YouTube, and this is probably one best left for the teachers. Where do you see this going? What kind of projects does this give you any ideas of what you can use in your classrooms? Kind of building on what Derek said.
Well, first and foremost, the first one that popped into my head is teaching rotation and of Earth and sunlight, and have the kids actually interact and be the demo itself. But then instead of, oh, do you see the light touching? Well, how much light? And really extend with that technology, and then play back. So now they can truly understand that there is less light throughout the day, or greater towards noontime and the like. And really, once those kids start getting that and understand how to integrate some of that technology, let them come up with different circumstances for different maybe altitudes or latitudes, and see where that goes with that easy demo that the kids could set up themselves and figure it out, rather than the teacher telling them, well, there's more light in the middle of the day than at sunset. Obviously, that makes intuitive sense, but they would see the data to show that.
Perfect.
Yeah, this really fits, I think, with the idea of moving to a continuity between home and school as well. The students bring in personal devices, and then we can use, with our BYOD policy, we can then make sure that everything's set up. They start an experiment at school, develop the curiosity, and then when they go home, they can continue with that. And I think this really fits with this making idea and this tinkering idea that we're trying to engender in the students.
Awesome, thanks.
Yeah. So with the demos done, and we have the teachers here, I want to spend the rest of our time of the webinar really spending time opening the floor to questions. The three rockstar teachers we have right now with us are actually, they have used the 101 in the classroom. All three of them have produced lesson plans. And so I think we're going to go some round robin style, Sean, and do kind of introductions in terms of what you teach, a little bit about the lesson plan you've created, and then what was some of the other things that we talked about?
How did the students react? Did you see any surprises, any good showcases, things you want to share about projects that they might have made, any surprises, good surprises that have come out of what students have created? And then what are some tips you can offer other teachers who are just starting out using the 101 or just any embedded electronics, because that's important, I think, for a lot of teachers who are just getting into this to know. So does anybody want to start with that? And I'm happy to repeat some of these if you need help.
Ian, let's start with you, because you kind of started with the youngest grade. I'm sorry if I cut anybody off, but I'm going to So
Good.
Ian, let's start with you because you probably worked with the youngest, and then we'll go with Nicholas second, and then Tony third. Is that okay with everybody?
Yeah, I've worked with all different year groups with this. So I've done it from, what would be your third graders all the way up to 12th graders. And I think this stuff needs time. And I think it also needs preparation. If you were just going to give the students the stuff to tinker with, give them an Arduino 101, give them a computer attached to it. There's so much. And I think this is all about some of the computational skills that we're trying to teach the student. You have to break it down into small chunks. You have to say, right, I'm now going to work on making this Arduino interactive. I'm now going to work on the program I need to write. I'm now going to make sure I've got the electronics set up. And I think, Sean, you were asking, what is the thing that you should share with another teacher? This is like trying to eat an elephant. You can't eat it in one go. You have to break it down into small, manageable chunks. And you just have a chew on one bit, you finish that, and then you move on to the next. Because otherwise, us grown-ups get confused. Imagine the poor kids. This is all very, very new to them. But for me, this is a most important thing. It's about exploration. And so I've spent a lot of time preparing worksheets, preparing resources, scaffolding the learning so the students don't charge into this. There is a journey. And so that when they then come again with something brand new again, they'll think, okay, when we did this before, what we did was we were disciplined and we just looked at one thing at a time. We got that working, we moved on to the next. So I think it's a great opportunity to engage the students' enthusiasms and appetites and ideas. But at the same time, we've got to make sure that they get the success. Otherwise, they'll say, I can't do that. I don't do tinkering. I don't do physical computing. And we need to make sure the initial experiences are successful and fun.
That sounds like great advice. Thank you.
Thank you.
Nick?
When I'm in my classroom, I try and do mainstream in pockets. When I first got the kit, I was doing after school, and then I'm like, well, wait a minute, let's do this with everybody and give everybody that experience. So when the kids reach a certain level of understanding of, I'm actually, take a step back, you said introduce yourself. I teach science at the middle grades level. And after school, I run a robotics club and coding club to help get kids exploring the stuff, and whether it's with their own devices and the Arduinos and just getting kids exposed. I find that to be very important. But going back in my classroom, once they have a baseline level of understanding, I use it to the different lessons. And like Ian was saying, I take them one step at a time. Okay, today I want you to do this task. And don't give them how to do it. Let them discover. That works on thinking, computational skills. Let them figure it out. Of course, be there as a guide. But like one of the favorite things I like to do is have them create a quiz over the content and use the blinking lights as A, B, C, D. So it blinks a certain pattern to say question one, answer was whatever, and so on and so forth. I like to explore the Arduino as if we were going on a field trip. I heard that advice before and am applying it to the technology. I don't remember where I heard that, but just going through education background. But I'm still the teacher and the technology is my assistant. That way the kids still, they need me to help guide them, but I provide them resources to help them with their learning. One of the neat, fun things that the kids like doing, they love making those quizzes and then trying to make them hard for each other. Well, you can't beat my quiz, and then it engages in that mentality, which also gets kids really engaged in content, but reading the academic language content class. But it's that they're having so much fun reading the science content, and that's really engaging. We've also, one project that some kids came up with going that route was using the LCD display as vocab word definition, just so that they can work on their coding skills and programming language. And they really, I've never seen kids enjoy learning vocab as much as that lesson. And that was, like I said, a couple really high flyers that need that extra push and differentiation. So, all right, well, let's figure out together how we can do that. That was what we came up with. But one of the tips I have is let the kids explore. And on the lesson plan Derek was talking about, all we did was we took a normal plain Jane projectile lab, and we hooked up an Arduino to it, and just a little simple server that would rotate backwards to get wind the catapult and then release it to launch it. And that was one of our very first ways of introducing that technology can be part of what we do every day in the classroom. That was one way that tech isn't always mainstream down here, and one way that I was trying to show a couple teachers that you can use the labs you've been using all along, it just a little bit by adding this extra component. That goes back to what Ian was saying also with give them one task at a time, and then by the time they get to Tony's age, they have a lot in their repertoire to pull from to be able to do some really great things.
Yeah. Very cool. I really like the idea of using the Arduino as a more precise control mechanism for some science experiments, because we all know, especially at the middle school level, right, to have a student sit there with a stopwatch is not always the most accurate thing. So to be able to use it to properly time and control experiments is a real good tool. So
absolutely.
Tony, your turn.
Cool, thank you. Yeah, I mean, my advice to teachers, they again, just make sure you're well prepared, and also just sort of tell the students not to be too ambitious to start off with. Certainly, how I've used the Arduino 101 in the classroom, we started a Genuino club, and really we promoted the Arduino board as a practical computer science lesson. And what we find at college is that we get quite a lot of males come in to do computer science, and what we're trying to do is close that gender gap, trying to get some females in there. So we've managed to do that, and some of our students come up with the idea of creating a lightsaber, which we took earlier this year. And again, it was just really getting students to think about what they're going to do, how they're going to do it. And we used other technologies like the 3D printer and CAD/CAM to come up with the design for the handle. It took them several attempts before they managed to create the final thing that was correct. And it was great. I mean, they were so happy to create the handle. But that took several weeks, and there was quite a lot of our students were pushing. You know, there was some there that really just wanted to push on with the Arduino stuff and the programming. And we're like, you know, it needs to slow down a little bit, let everyone participate. We're also trying to model employability skills. Certainly, college students they go on to university or they leave to go into employment, and employers are saying to us, can you help develop the softer skills, the team building, the communication, the problem solving, and I think using the Arduino 101 as a practical sort of computer science lessons will really help him close that gap as well. So yeah, I mean, my sort of advice to teachers is to take it a step at a time, be well prepared, give the students the freedom to explore and have a look at what they would want to do, but use other technologies out there as well to complement the Arduino 101 projects, and eventually students will just take ownership of the project, and should just step back a little bit. Yeah.
Awesome, thank you, Tony. If anybody wants to input on this question, this is one that comes up a lot of times here as well, is how do we tie some of this, what we're doing, we're learning STEM, we're learning embedded electronics, how do we tie that to standards? And specifically, how do you assess your students' abilities and how well they're doing? I think that's a tough one that comes up. So if anybody wants to jump in and answer that one, what do you guys do?
Yeah.
That's most definitely a huge piece also of how can we justify using this? And so you don't, for me personally, I don't evaluate them on using the tech. I use that as a method to stretch their thinking. It's the connections that they make with the activity and then applying it back to the directly tying the academic language with building different applications. And I'm gonna look into the app and have kids build some apps using that and using the language and vocabulary that we are currently studying.
Yeah. Nicholas, that's actually, you bring up a really good point, in that we kind of, in our education department, we look at this tech sometimes as either learning material, my students are building something and they're learning through building, or a teaching tool. As a teacher, I'm using this as a way to then further their knowledge about something else, and I think that's a perfect example of a teaching tool, right? The Arduino learning programming and stuff on that's not the goal. The goal is, how do they prove that they learned in something else, and using this as something that, like a overhead projector or a smart board, it becomes the same type of material.
Yeah, I agree with you, Derek. I mean, it's like if you were studying physics, you'd be doing the theory and you need to be able to consolidate by applying that theory to a real situation. And the Arduino makes that possible. But I think there's a whole other level that's really important here. It's the computational thinking. It's, all the stuff that all the skills that we've been using and we use as adults all the time. We break a problem down into small chunks, as I mentioned earlier. We look at patterns and trends. We're constantly trying to abstract, to try and get rid of the nonsense, and then be able to understand how we can solve a specific problem and understand the simplicity of the problem, so we can solve that first and perhaps add those other levels we've abstracted out later. This is a fundamental set of skills that we need students to develop, and there isn't a better way than doing it than getting them to fail and tinker with a device. And because none of this stuff is going to work out of the box, even when you join it up, even with a very prescriptive workflow, it's still not going to work first time. And I think that experimentation and that opportunity for the students to learn these computational skills, I think, is fundamental.
Yeah, it never works on demo day.
Oh no. Yours worked.
Sort of.
There was some hand waving going on. No, not really.
But sort of is good enough, because sort of is probably what we most of us have to deal with day to day. And it's how you deal with the sort of, and how you fix and iterate so you can get it so it's good enough. And that's a skill that you can apply to any part of your life.
Yeah, so true.
I think, talking about what you were saying, Ian, I think that's most important. Fail means first attempt in learning. And We expect our students to be great problem solvers and know how to do this and that and everything else. But if they're not, how do we teach them to be better thinkers? And this is one of the ways that I try and address that. I completely agree with what you were saying about that.
And I think industry and you know, we have talking about a curriculum. We have a national curriculum. We're the only country in the world to have a national curriculum for computer science. And right in the first paragraph, it says computational thinking and creativity. These are the things that we want every student to get out of a computer science curriculum. And whether it's in the classroom or, you know, in the club, it doesn't really matter. This is what we're trying to achieve.
Great. Thank you, guys.
I have one more question for them, actually.
Go for it.
You know, as teachers, we're always thinking about what next, and I'm really curious with you guys. What are you planning? What is going to be new in your classrooms next year? How are you going to kind of the modification, the little nudge or tweak here and there? What are you going to be changing in your classrooms around the Arduino 101 and tech in the coming year?
For me, it's getting devices talking to each other, and that's why I really enjoyed what you did, Derek, today. You know, with Blink and with the Google Science app, because as I said, we're trying to get students to have a personal device that they look after and they build up the tools that to help them with their curiosity. You know, they want to find out about stuff. They have a personal device and they can use it for that. And I think what we need to be doing is encouraging the tech industry to write the sort of apps and the sort of web-based software that students will be able to use to interact with things. This whole IoT thing is going to be all pervasive. And the more the students get on board to understand that by doing it, the better they're going to be able to take part in this world that they're going to inherit from us, and the better they're going to be able to try and make that world a better place. And I think that's what is the next step for me, because I think without that, we're not going to be doing the right thing by the students.
I really want to extend the way that teachers use the tech or integrate. I think that as we were talking, using the to help, and the sensors really to extend some of the things we're already doing. I think that one of the things a lot of teachers are hesitant, oh, well, we can't learn that. Oh, no. But it's really using the same things that you're already doing and just extending that a little bit and relinquishing some of the control for students. And I also think that, you know, if we let the kids use some of these apps themselves, we have a fair number in our particular district, but that's not the case always, that if the kids have the ownership in the classroom by Blink or the Science Journal app to record that live data, we can do leaps and bounds with sitting here thinking about that. We're going into ecology, and we could take the light sensor app and see why these plants make that connection of these plants grow here, these plants grow here, these plants grow here. And why doesn't this one survive in bright sunlight? But it's using some of those temperature and light sensors to help with that, interacting with their environment rather than with a textbook.
Yeah, nothing wrong with textbooks, but we want the hands-on learning, don't we?
To go with it, yes.
Yeah, we do.
Yeah, it's the consolidation. It's where you bring it to life, and it's where you know, we all work with text in different ways. Whether we can just read something, understand it, or whether we need to go back over it a few times. But understanding, consolidating, this is the way to engage the students, and also to make the learning real and memorable.
Yeah, if they don't make the memories, they're not going to retain it either.
Just be fun, isn't it?
Absolutely.
How about you, Tony?
So for us, I think what we plan on doing, similar to Ian, is certainly using more apps to connect different devices together. Again, I mean, we're quite fortunate that we've got 3D printers and everything else at our college, and Lightsaber was the first sort of project that we were able to use and get students thinking outside the box and being quite ambitious with their projects. So for us, we're looking at using other technologies that would work together so students can create bigger projects using the Arduino 101. And actually, Derek, I'm quite looking forward to hearing about the Scratch extension because I do quite a lot of stuff at primary schools. So in hearing your thoughts on that.
Perfect. Actually, I totally forgot to mention it.
I got you. I was gonna remind you right after this.
Thank you.
It's actually a good segue into it right now.
Yeah, so scratchx.org, and scratchx.org is kind of the experimental, open experimental place where we can kind of dump things in terms of different plugins and things like that that we can interact with in terms of Scratch. And let's go here. And so I've gone to scratchx.org. Again, it is a beta piece of software, so it is a little, I wouldn't call it buggy, but it's beta, right? So there's some holes it's being worked on, things like that. And what Scratch does is allows for us, they call them extensions. It's kind of like what if you're coming from the Arduino world, it's similar to a library. And they have all these different extensions for ScratchX, including one for the 101. And so you can click on the documentation, and it brings up a GitHub link to it, and we're going to share all these links out as well. It gives a quick introduction about using the Arduino or Genuino 101, depending on where you are in the world, the hardware you need, software, and getting started. And the getting started page takes you step by step here to be able to say, hey, here's the sketch you need, and moving forward in it. And then currently at this time, again, part of this being the beta, is that this extension only works with the Firefox browser window. So if you're a Chrome user, you might have to wait a little bit or see if you can download Firefox. But that is kind of where it is, and it takes you step by step. There is some examples. There's an example of just writing blink. Yes, understand, continue. Writing blink for it, again, programming it so it produces these blocks that are specifically designed to control the Arduino 101. And I can set the pin that I want to control, and I can set it either on or off if it's a digital pin, or a percentage if it's a PWM pin. Things like you can also read the analog pins. When shaken is nice because of the onboard accelerometer on the 101. It will actually detect motion. So if I shake the 101, have something happen in Scratch, the great thing about being able to set pins is that I can now start creating kind of a control panel in Scratch. So if my character, if the ball goes off the screen in Pong, an LED blinks, which is pretty cool. So getting creativity on the screen, off the screen, and the other way around. So that's kind of ScratchX, the ScratchX extension in a nutshell.
Nice. Do any of the teachers have experience with Scratch? What do you think about it in general, and about incorporating maybe the 101 or some other sensors, lights, and things you can do in a hardware sense?
Well, it's the next step. Go on.
Go on, Ian.
It's the next step. I mean, I think Scratch is now all pervasive across the whole world. And, I was lucky to talk to Mitch Resnick last year about this and how passionate he is about joining up the Arduino with Scratch. He talks about it lowering the floor of access to using Scratch. And I think it is the next step, and it's what we're doing. I'm obviously the Firefox browser will cause some schools issues because it's not going to be it's not currently the browser of choice because it's got too many holes in it, and it would allow our boys to do bad things on the network. And as much as that would be a good hacking project, we don't really need that. But I think when it becomes more mainstream, because ScratchX, we've already been working with ScratchX. There's so many great extensions in there, and I'm delighted that it's going to work for the Arduino.
Yeah, I do a lot of work with primary schools and helping teachers with the computer science curriculum. And you can do with Scratch in terms of projects and stuff. And then I think, I'm really excited about Scratch working with Arduino 101 because then we can really start showing students sensors and getting the hardware out and getting them to see if you're going to build a program, this is how it's going to work with hardware. This is a real life scenario. So I'm really excited. And again, I've just sort of agree with Ian on the browser issue. But hopefully, we can look forward to something in the near future.
Yeah, and usually Lifelong Kindergarten Lab and Scratch, the people who work on Scratch tend to realize this and understand it. And so I would say in the future it'll support Chrome and all major browsers at some point in time. So
I think Nicholas had something to say on this.
Yeah.
Oh, I was just going to say that I love using Scratch. It's a great entryway. I've got when my son was in kindergarten working and making stories, and I'm really looking forward to the way that we can blend it with our Arduino boards to really make it go from just computer theory world to, wait a minute, this is blinking in real life, or this is doing whatever else with those pins, to show kids that things that we do in computer are prominent elsewhere also, and how the two worlds interconnect.
Perfect. Well, I'm going to open it up for you guys. If you want any kind of last closing comments from our master teachers, because we are a couple minutes over, and I want to be respect their time. I know we have other meetings and things that we all need to get to. So we'll let you guys have kind of final comments, and then probably see if we have any more YouTube questions for the teachers, or that Sean or I can answer. So Ian, we'll start with you and let you take it away.
I think, I don't really reiterate what I've said. This stuff is a great opportunity to get students exploring. Have a look at the worksheets that we've done that are online, on the Intel site, because, a lot of time and effort's gone into that. And I think if you start, even if you just look through the stuff, look through the literature, look through the worksheets and work it out, it'll give you an idea of some things that work, and it'll give you an idea on how we are decomposing the use of this technology for students. Okay, thanks. And thanks for inviting us, Derek. I really appreciate it. This is
No problem.
The
honor is ours.
Yeah, cheers.
Nicholas, you got anything?
Say that biggest thing is to be willing. I thought that it was actually great that the demo didn't work right at the exact moment, because the thing is that I run into is teachers are like, oh, well, that works for you, but that would never work for me. Well, just take a leap of faith and try. One thing I do, even though I integrate it lots of different ways, is I still go back to the Intel website, Engaged, that has all of those lesson plans, and it's okay to have that little activity, even if they're only doing one tiny little thing, but then that really links the kids' learning to a memory, and when they remember it and they want to be there, the learning will happen.
And Tony?
Yeah, so just to sort of wrap up, for the new teachers, the biggest thing I would say is just let your students explore. There's some great stuff on the SparkFun website, some lessons on there. Again, we've done quite a lot with the Intel stuff. And there's loads of other websites out there that are really useful just to get your students thinking about projects that they can do. And let them fail and work through projects, because that's the way that they're going to learn. And as teachers, I would recommend just taking a step back and letting students take ownership of the project. It's all very practical, hands-on. Enjoy it.
Great, thank you. We have a couple of questions from YouTube. Which language do you use to program in Arduino? And it's a combination of C and C++. It's kind of its own language, but in reality you're doing C++, and it's built around a framework, so you're calling a lot of things on the back end that you're not seeing. Like, there's no main anymore. It's all in the back end of the Arduino framework, so you use some stuff that's just given to you up front for functions, but it's C++, it's a combination.
Yeah, the short answer of that is it's if C and C++ had a baby, you'd get Arduino.
Meant for microcontrollers.
Yes.
Yeah. And then another one, you may have already covered this, but are there any drawbacks to the Arduino 101 versus the Uno/Redboard?
In terms of drawbacks, it's a little more finicky and sensitive. So all the GPIO is 3.3 volts rather than an Uno being 5. It is 5 volt. It's safe. You're not going to blow something up. But that is kind of a gotcha for a lot of classrooms, especially if you're transitioning from an Uno where your students are used to using 5 volts to something like the 101. You also have to have the board definitions installed to use the software, or to be able to program it with Arduino. It doesn't come pre-done, and you do that through the board manager and the Arduino software. So it is something that you have to spend some time pre-loading on the computers that students will be programming on.
Yeah, and then another comment somebody posted, not all libraries made for the Uno will work with the 101. And that's true for a lot of different Arduino platforms. Something made for the Uno may or may not work for other platforms you will find for Arduino.
Yeah, I mean, that you kind of run into that as you explore different boards. One of the libraries that I'm really interested in using that isn't really, you can't use it with the 101 at this time, is the infrared IR remote control library. I'd like to be able to read when I press the volume button on my TV remote. I can read it, but I can't write with the 101 in terms of using an IR LED. So this stuff tends to come in time. All it takes is an engineer to be like, I really want this to work, and they end up rewriting the library for it. So that's part of community supported hardware. It doesn't all work right away, but over time, and as things mature, things happen and get more support.
Yeah. Great, thank you everybody for your comments. To wrap up here, if you haven't done so, make sure you register for this webinar at sparkfuneducation.com/webinar/arduino101.html. If you do this, you have a chance to win a 101 SIK lab pack, and that's 10 full SIKs with the 101 in it. Let's see, one more question popped up. If I replace the red boards in my SIK with 101s, would they still work with all of the SIK experiments, or would that 3.3 volt, 5 volt thing be an issue?
No, all of them should work. The 101 SIK is essentially, we took our original Inventor kit and we added some components that we thought would be really interesting to use with the 101, and then went from there. So pretty much all the experiments are the same. Check out the experiment guide for the 101 SIK, because that gives you some of those basic diagrams. Anytime you would use 5.5 volts, 5 volts in a standard Uno format, you just replace that with 3.3 volts is the general rule.
Yeah, and the only thing I can think is maybe if there's a servo example, you'd have to use the V-in instead of the regulated 3.3 volts.
V-in, and
5 volts.
There's also a 5 volt pin on the 101. So you still have access to 5 volts to be able to use motors and the servo as well. So that doesn't change. Yeah.
Right. Great, and here we go. How are you entered to win the class pack? Just by registering? I believe it's a random drawing if you register on that site.
So if you register, we draw a random name, and we'll contact you to be able to get all the shipping information from you. It's all the names from this version of the webinar, our first one, as well as some names from the in-person workshop I gave at BET. So pretty good sized list. If you are a teacher that's out there using this and you want to be able to share your content, a great place to do that is invent.sparkfun.com. That's kind of our online repository of lesson plans and activities to do with your classroom. We're also going to be tweeting out the link for the Rockstar Teacher lesson plans from the Intel site. So you'll be able to look through their lesson plans, see how they did this. Ian did a great job of a self-driving car, and it's actually a series of lesson plans. And then if you have any questions directly for us as well, you can education@sparkfun.com is the email address that you can send them to, and somebody in our education department will get back to you. Might be me, might be somebody else, but probably will end up being me if it's 101 related.
Great, I think that's everything. Thanks everybody for joining us.
Yeah, thank you.